Oh, God. Tony asked, did we randomly just choose two starting numbers?
Okay, so I chose that question because they're given the numbers. They gave the numbers to me, but I would assume we would have to find them ourselves. But I guess, like, for something like this, you can do 0 and 1. But for Secant Method, I think they would always give it to us, because it's a very tedious thing.
But if they don't, would you just say to go with 0 and 1?
I'm not sure. Not for this. This one I wouldn't try. Because look, if I started with 0 and 1,
numbers are really close.
I would never get to that.
Yeah, you'd
answer.
take forever.
I would hope so.
We'll just have to wait and see.
It's not just that, by the way. For the bisection method, you'll see why. You have to be very careful with bisection method. Because there's a rule you need to follow for it to work.
That's not given in the formula.
So basically the bisection method is, you get two values, you have a lower limit and an upper limit, and you're going to find the value that's in between them. Obviously that's easy, that's just the lower plus the upper divided by 2. But the thing is, you then have to decide which value to keep and which value to discard. And let's follow those rules. Where's the thing for the x new? Okay. So this is how to find the x new. Obviously, as you can see, it's easy. I've got an example I can actually use. Let's see. This is an example I made myself because I couldn't find a good answer to use. I mean, a good question to use. Okay, so I'm just gonna do 3 iterations of bisection methods so I can explain to you what we have to do. So essentially, we've got to find a function of xl and x new to find out what value to change to. And I've got this here, and I'm gonna copy and paste it. It's a formula I made so I can remember stuff. Okay, so this is essentially how it works. So if the value we get after timesing the function of xl and x new is greater than 0, then x new will become xl. Or if it's less than 0, that means if the signs change, then it will become xu. L stands for lower, U stands for upper, if you didn't know that yet. Okay, so let's do one iteration at a time. So iteration. Iteration 1. The function is x cubed minus 20, x the value of xl, and then you do the function of xl. This is not a question that we got in the paper, by the way. I have to make that clear.
What did you say?
We don't get this question in the paper. This question is to explain how to use it.
Okay.
So don't expect like to know just from this. You need to practice, basically.
Yeah.
And let's do that then. The function. Oh no, we need an x new as well. So, I mean, it's not too hard, but you just gotta remember these things. So which value goes to xl or xu. So for xl we start with 1 and xu is 4. So since I'm not going to need the function of xu, I'm not going to put it on the actual on the table. That's what I mean. To find x new, as it's been said, it will be. I'm gonna do the first one. X new will be 1 plus 4 divided by 2. So that's a 4, not a 9. 1 plus 4 divided by 2, which is 2.5, and that's the value of x new. So 2.5. Okay, now function of xl is putting 1 into the equation. That will be 1 minus 20, so that will come to minus 19. And now the function of x new will be putting 2.5 to the power of 3 minus 20, and that gives minus 4.375. Okay, now this is where you stop and think first. So you gotta times that value, so the function of x new by the function of xl, to decide which one of these x new goes into. So yeah, so as you can see, they're both the same sign, so you'll come up to positive, and that's greater than 0. So x new will go to xl. So x new 2.5 is the new xl value. Okay, so if they're greater than 0, then x new is xl. If they're less than 0, x new is xu. So xu will stay the same, and we have worked out function of xl over here because it's the same value. So it's minus 4.375, and now we got to find the x new based on the new brackets. So 2.5 plus 4 divided by 2 is 3.25, and the function for that is 3.25 cubed divided by 20. I mean minus 20, not divided. And that is positive. That is a positive value. That is 14.32813. Okay, now because the signs have changed, that means it will be a negative value. Negative will be less than 0 then. So x new, the value that we got for x new, will go to xu, and that is 3.25, and xl will stay the same, and that is minus 4.375, and that is 14.32813. And now just work out with that value then. So that value cubed minus 20 is wait, did I miss something? Oh, okay. 3.25. Oh yeah, we need to work out x new, not this. This is not a function. Okay, so this is x new, so it's 3.25 plus 2.5 divided by 2, which is 2.875. and then you work out the function for this, and that will be 3 iterations done. Okay, so this is the value for the third iteration. And yeah, you could just keep on going now. But that's essentially how to do the bisection method. You gotta make sure you put the x new value into the right column on your table. So yeah, that's bisection method. Any questions?
How do you do the bisection method?
Yeah, that's what I was gonna say.
What?
What's so bad about it? I mean, it's one of the easiest, as in working out wise.
Oh man.
Which part don't you get? Like where to place the things?
Let me just try and... Yeah. Okay, so...
It's not that bad. Like you just
I see where you... Oh, with that.
you see the value you get for fx new. This one. You times it by the value you get for fxl, and then you either get a negative or a positive value.
Yeah.
So, and then you pay based on that answer, you decide where the value of x new goes into, and that's what you do.
Even Larry's confused. When I was talking to, he's just confused. Okay.
What?
Let me
What?
try this.
Is it break time?
No,
I think it is.
it's not break time.
I don't think you should do it anymore.
I'm gonna do hashing and then finish. I'm not gonna do complexity again. We did complexity last time, and we're probably gonna do complexity tomorrow, anyways.
Is Biwi confused?
He doesn't
I don't get
understand what
what it
it does. It just breaks it down. Like it breaks down the thing into chunks, and the chunks keep on getting smaller and smaller and smaller and smaller. This is called a binary search method as well.
How long is the break gonna be? Because I mean, like,
There's not going to be a break.
After hashing. Oh, we're not doing complexity anymore.
No, I'm not going to do a break. As soon
No,
as
we
I
did
finish
that last
hashing, I'm going to go.
Okay, alright. So we're just doing hashing tonight, and that's it.
Yeah, I'm going to go through the
Okay, you
hashing
can help.
question.
You can help me with complexity tomorrow.
You
Yeah,
can
just
help me
come
with that
along.
one.
Like
Alright.
the more people there that come, the more people help, basically.
Okay, let me write down that question. Well, it'll be on the stream, but I can't be bothered. X.
And I'm not coming Tuesday, by the way. I'm coming Monday, but not Tuesday. And I need to relax before the exam. I don't usually
He hasn't
study.
given us any questions on the bisection method, has he?
It has, but it's not really good questions. You get it? So, like, there are questions in the tutorial. It says for the question I did on Newton-Raphson,
Yeah.
it basically gives us something like how many iterations you think it will take for the interval bisection method to find the same answer. Yeah, what would you answer to that?
No idea.
Exactly. And then try this again, but this time with the interval bisection method for about 5 iterations. How close do you think you are to the solution? So basically we'll do the same thing I just did, but for the bisection method. I mean, I'm not sure if we'll get a question like this in the exam, but we could.
Okay.
And if you understand the basics of the bisection method, which I just did, then you'll be able to do it. They usually make you do into intervals, basically. I mean iterations, not intervals. That's the only question I can see, actually.
Ah.
Oh, that was quick.
Yep.
Yeah, I'm not gonna eat now. I'm gonna